Hello everyone, welcome once again to Mr. Hallelujah Maths class. Today we'll be looking at geometry progression part 2. Alright, let us quickly, without wasting time, look at the list of numbers that we have already. Like in our previous edition, we said that the common ratio here is 3. And we were able to deduce it by saying that the second term divided by the first term, or the third term divided by the second term, or the fourth term divided by the third term. That will give us our common ratio. And we went further to say that the pattern for geometry progression or geometry sequence, as the case may be, is based on multiplication and division. All right, now that is just a review of what we did in the part 1 edition. All right, now let us talk about how to look for the nth term in a geometry progression. Now we have a formula that we use: n subscript a subscript n equal to a subscript 1, which is the first term, multiplied by our common ratio raised to n minus 1. All right, now as it is right now, let us look for the fifth term. Let us look for the fifth term, and in that case n will be equal to 5. Let us look for the fifth term from this our sequence. So let's see if this formula will actually work for us to look for any term at all of your choice. So now a subscript 5, we say that n will be what? Will be 5. So our first term from the sequence is 1. All right, and we say that our common difference is 3 raised to the power of 5 minus 1, which is 4. So on that note now, 1 will multiply everything here to still give us what is inside the bracket. So it simply means that 3 raised to the power of 4. Our fifth term will be 3 raised to the power of 4. Now 3 raised to the power of 4, it simply means 3 times 3 times 3 times 3. That will give us 81. So if you look at the sequence now, you agree with me that our fifth term, 1, 2, 3, 4, 5, this is our fifth term, is 81. So this formula proves correct that our fifth term is 81. All right, thank you very much about that. So let us talk about how to look for the sum of let's say the first 5 terms. Now this has to do with geometry sequence or geometric progression, as the case may be. Let's solve for how to look for the first 5 terms, the sum of the first 5 terms. Now when we want to look for the sum, there's a formula that is generally accepted. Say x sub n equal to the a sub 1, which is the first term, in bracket 1 minus arrow, which is the ratio raised to the power of n, all over 1 minus arrow. Now this is the formula that is accepted generally, and we know that, let me demarcate, and we know that a is our, let's look for the sum of the first 5 term. Okay, so x subscript 5, because we are looking for the first 5 term, n becomes 5, and we know our first term to be 1, all into 1 minus our common ratio. We say that is 3 already. We say that is 3 raised to the power of n, which is 5, bracket close, all over 1 minus 3. All right, now 3 raised to the power of 5. 3 raised to the power of 5, meaning 3 times 3 times 3 times 3 times 3. That will give us 243. So it simply means that we will rewrite as s subscript 5 equal to 1 here does not mean anything, because 1 multiplying all inside this bracket will still give us what is inside the bracket. So 1 minus 243 all over 1 minus 3, which will give us minus 2. On that note, now we have to subtract 243 from 1, which will give us negative 242 all over negative 2. Minus divide minus will give us a positive answer. So when we do this division, 242 divided by 2 will give us 121. Now to prove that the sum of the first 5 terms is actually 121, if you sum up these first 5 terms, 1, 3, 9, 27, 81, it will give you 129. So do well to do the summation yourself and confirm the answer. Meanwhile, thanks for watching. Do well to follow the page. Do well to like and comment. Mr. Hallelujah Maths class is here for you. Bye bye.